In honor of the ongoing mass protests in the United States, we're going to be talking about a paper by Vitriol, Appleby, and Borgida. Racial bias increases false identification of black suspects in simultaneous lineups, in the August 2019 issue of the Journal of Social Psychological and Personality Science. If you'd like to read the paper for yourself, check the description for a link and citation. The other race effect, as I call it, has gone by a number of different names. The phenomenon itself has been extensively studied in face research literature. In short, people are not as good at identifying and differentiating the faces of people of a race different than their own. Pop culture's examples of this include people thinking that all Asian women look the same, and police mistaking one black man for another. Two different theories have been posited to explain this, and I should note that they both have good evidence to support them and are not mutually exclusive. The first is that people gain increased proficiency with faces of the same race as them, since they tend to hang around those people the most. The second is that people categorize people of different races as outgroup, and thus spend less mental energy differentiating them. As you might expect, the other race effect has some serious implications in criminal justice land. Eyewitness testimony is super common and relied upon to figure out who done it. As anyone who's taken a class of memory knows, memory systems can be quite faulty. Furthermore, viewing conditions and even how you arrange your lineup can lead to false identifications. In fact, other race identifications were present in 30% of the documented wrongful convictions Innocence Project was able to overturn. So it's kind of always been assumed that racial bias was correlated with the other race effect, but the evidence for it has been somewhat mixed. In fact, a 2001 meta-analysis by Meister and Brigham found no evidence for a link. However, most of the prior research has been done with sequential lineups, which are actually better if we want to increase our correct identification rate and decrease our false positive rate. So in theory, a simultaneous lineup, like what you would see in movies and TV, might be better at revealing the association we think is there. Furthermore, prior research hasn't used implicit measures of racial bias. It should also be noted that the more modern measures of explicit attitudes are much more sensitive than the ones we used in the past. I might go into why that is in a future video, but this one is going to run long, so we'll move ahead. For their first study, the authors recruited a fairly large undergraduate sample. Fortunately for them, they were able to sidestep a major limitation of undergraduate samples in that they only used Caucasian individuals for their analysis. Interestingly enough, the other race effect doesn't appear as strong going in the reverse direction, e.g. blacks viewing white faces. But that is a whole topic for another video. The participants had 2 lab visits. On the first, they simply completed the individual difference measures, which included 1 of 2 implicit association tasks, and 2 measures of explicit racial bias. On the second visit, they underwent a crime-prime paradigm in which they were randomized to be either primed to think about crime, or they were given a dummy treatment. Since the authors used an implicit association task to measure implicit racial bias, I want to spend some time talking about them. I.A.Ts are said to measure exactly what you'd expect. To do this, they display 2 categories and then, in this example, the words good and bad. You, as the participant, are then expected to press one of 2 keys. If you see a member of one category or a positive descriptor, you then press one key, and if you see a member of the other category or a negative descriptor, you press a different key. There are multiple phases. In each phase, which category goes with the positive or negative side changes. In short, the theory is that if you're biased in favor of one category and against another, you'll be quicker and more accurate in pressing the key for that category when it is paired with a positive descriptor, and vice versa. You might think that I.A.Ts would be hailed as the magical measure of racial biases, among other biases, but it's actually fairly controversial. To be fair, the task has some serious upsides in that it is well established and standardized. It's also pretty easy to administer. And the hope is that we can get a better measure of bias using an I.A.T, especially when looking at subjects that are more socially sensitive. For example, no one wants to admit to being a racist, even if they actually are. On the flip side, critics of the I.A.T have lodged some quite valid complaints. I.A.Ts don't have the best test-retest reliability. That is, when you re-administer the test after a reasonable delay, like a couple weeks, the results aren't going to be as consistent as we'd like. It also does not distinguish between pure in-group favoritism and discrimination against an outgroup. Also, I.A.Ts aren't super great predictors of downstream behavior. So with those caveats, we will press forward. The authors used 2 different measures of explicit racial bias. The first is the symbolic racism scale, which measures the extent to which participants believe that prejudice against blacks no longer exists, that racial disparities are the result of failings in black culture, and that efforts to remediate disparities between blacks and whites are unneeded and/or counterproductive. The second is a measure that sought to determine how much participants endorsed common stereotypes about black people. They were asked to rate on a scale from 0 to 100 how much the average white American believes that the three traits you see here describe black Americans and white Americans. The aggregate score for beliefs about white Americans was subtracted from the score for black Americans. Thus, higher scores indicate a greater endorsement of stereotypes about black people. We can generally assume this since people tend to use themselves as a heuristic for describing how other people think. So, if you think other people think a certain way, there's a decent likelihood that you yourself think that way. For the crime prime manipulation, participants were told that they were going to complete an attention task. They were told to focus their eyes on the center of their computer screens, then select the corner in which an image appeared. Then, a mask would be displayed. A mask in this context is a pixelated blur that prevents your eyes from seeing any kind of after image. Each priming image would appear for 25 milliseconds in one of the corners of the screen. Then the mask would reappear until the participants made their selection. They would do 10 practice trials and then 4 blocks of 25 trials each. In the crime priming condition, the images that would flash were one of 4 crime-related images you see here. In the non-priming condition, an indistinguishable amalgam image would flash. The participants were shown 2 blocks of 5 target photos. One block consisted of white faces and the other of black faces. The order of the blocks, by the way, was counterbalanced to protect against order effects. Each face would be shown for a random amount of time between 3 and 10 seconds to better simulate real-world conditions. During the memory stage, the participants were shown 5 different lineups. 2 were target present, one face is familiar, and 3 were target absent, all faces are new. They were then asked to determine whether one of the 6 faces was seen before, or if none were seen before. Now, a note about face research and lineups. Photo sets for this kind of research are incredibly difficult to get, not because the proper photos aren't readily available, but because developing good sets is really hard. You need to make sure that none of the target faces and none of the lineups are too easy or too hard. An easier lineup would include faces that are really distinct, whereas a harder one would have faces that all look really similar. In this case, you also have to ensure that the white lineups are just as difficult as the black lineups. In short, it's a giant pain in the butt. Thankfully, the authors talked all about their whole process for creating these lineups in their supplemental materials, so if you're interested, give those a read. Before we get into the results, I want to talk about signal detection theory as it relates to face memory research. There are 4 possible outcomes of a given trial. Either the task will have a previously viewed face present, or it will not, and the participant will say that the target is the face they had to remember, or it is not. If the participant says yes, and it is the correct face, you get a correct identification. If the participant says yes, and it is not the correct face, you get a false identification. If the participant says no, and it is the correct face, you get an incorrect rejection. If the participant says no, and it is not the correct face, you have a correct rejection. All of these are different ways of looking at how accurate your participants are, but for us, the most important are the correct identification rate and the false identification rate. Although correct rejections are also important for determining response bias. As this is a simultaneous lineup study, if someone is presented with a target present lineup but selects the wrong person, that would also be classified as a false identification. The authors also included 2 other elements of signal detection theory, and those are the 2 dimensions of recognition memory. The first is discrimination accuracy, or the ability to differentiate between the signal, the target face, and noise, filler faces. The second is response bias, or the level of certainty a participant needs before they say whether a stimulus has been seen before. I want to give a small shout out to the authors because they provided nice graphs with 95% confidence interval error bars, and to honor them I really wanted to include their graphs here. But unfortunately the images weren't big enough, so you're stuck with mine. As I've stated before, 95% confidence interval error bars are much better because that metric makes it easier to eyeball which differences are significant. Shown here are the effects of the crime prime manipulation. Based on the information the authors gave in the supplemental materials, I felt it easier to create this unstandardized regression coefficient map than a series of bar charts of the marginal means like they included in the paper. In simple terms, each dot represents the unstandardized regression coefficient for the crime prime manipulation in predicting these various measures of accuracy. If the 95% confidence interval does not include 0, then there is a significant difference between the crime prime condition and the control condition. The only significant difference found was that the participants returned more false identifications for black faces in the crime prime condition. Regarding face-by-face comparisons, the authors were able to replicate the other race effect. Here we see that false identifications were much higher for black targets than white targets, correct identifications were really lower for black targets than white targets, discrimination accuracy was also much lower for black targets than white targets, and response bias was higher for black targets than white targets. In simple terms, the participants were worse at discriminating between black faces and had a lower threshold of certainty to decide that it was the person. And now the racial bias results. They found that both of the explicit measures of racial bias significantly predicted the false positive rate for black targets, such that more biased individuals picked the wrong face more often. The I.A.Ts did not have any predictive value. Here we see that one of the I.A.Ts negatively predicted correct identifications for white faces, but my inclination is that that finding is spurious since the other I.A.T doesn't match that association at all. There were no significant associations regarding discrimination accuracy. Again, that stereotype I.A.T seems to be a rogue measure. Not sure what to make of that. Also, black versus white stereotype endorsement significantly predicted response bias such that greater belief that the stereotypes hold was associated with a more conservative response bias. In other words, they needed a higher level of certainty to say that the target was a familiar face. Since their first study provided interesting results, the authors wanted to replicate those findings in a more representative sample. Undergraduate samples, while extremely common, are, for a number of reasons, not particularly representative of the general population. And now on to Study 2 results. They were able to once again replicate the other race effect with data that mimic the differences found in Study 1. Regarding racial bias results, they are largely a replication of Study 1, but let's go through them one by one. Symbolic racism was associated with more false identifications for black targets and white targets. Symbolic racism was associated with fewer correct identifications for black faces than white faces. And symbolic racism was also associated with poor discrimination accuracy for black targets, but not with white targets. There were no significant associations with racial bias and response bias. So the big takeaway here is that we have even more evidence for the other race effect being a thing. We also now have some pretty good evidence that racial bias plays some role in this phenomenon. Regarding limitations, I think we have one more case of the implicit association task continuing to disappoint regarding downstream behavior. While there were a few significant associations, they weren't consistent enough for me to give them much worth. I really like the theory and the potential of I.A.T, but it just hasn't provided the results we need to really rely on it. Also, the paper really pushed the crime prime manipulation, but I'm not super convinced. The fact that it only showed a significant difference in false identifications and not in any of the other metrics is a little concerning. I would definitely like to see some more work with priming crime before I wholeheartedly believe those results. Also, I should note that just seeing a headshot for a short period doesn't particularly reflect how we see faces in the real world, so this study was a little lacking in external validity. I would love to see some replications that use higher external validity. This study had excellent internal validity, that is, how well your study measures what you want to measure. However, this came at the expense of limited generalizability. In a future study, instead of doing that crime prime manipulation and just showing the faces on the screen for a few seconds, maybe you could show the participants a video of an in-progress crime or a non-crime scene with the same target person. You could also do similar manipulations with different black stereotypes. I would also be interested in a closer replication of this study, but with a sequential lineup instead of simultaneous. Well, that's all I've got for this paper. The recent murders of George Floyd, Breonna Taylor, and Elijah McClain, to name a few, remind us that regarding racial justice we have a long way to go in this country. I hope that my dissection of this paper has illuminated one more way in which the criminal justice system does not favor people of color. As always, please like, share, and subscribe. If you've got a paper you'd like me to dissect, or have further thoughts on this one, let me know in the comments.